significant figures in addition, if we want to calculate the sum of three measurements and give the answer to the correct number of significant digits, when we're adding, subtracting, it's all about place value. It's all about how significant, what place did you take it to. That's what's important. It's not about how many you have to start with, how many you end up if you add them all together. It's about place. So in other words, this first one was measured to the nearest hundredth, the second one only to the nearest tenth, and the third one to the nearest hundredth. Understand that those ones measured to the nearest hundredth, those might be pretty accurate, and that's great, but the one in the middle, measured to the nearest tenth, the error on that one is what takes care of it all. I mean, no matter how accurate you did the other two, that error is much more significant. Therefore, my answer has to go to the nearest tenth. So the way that I do it is I just add it up like normal. So I get a 6, I get a 7, I get 9, carry the 1, 6, 3. And then I round off to this place. So this is saying I want to round off to the nearest tenth. This is going to make it go up. So my answer is 369.8. It's all about place value. That's the important thing. All right, so work problems 5 and 6. Stop the video, come back, and we'll talk about it. Okay, for A, you've got 61.2, 9.35, and 8, oops, not put that there, 8.6. And I want to add all these up. Once again, nearest tenth, nearest tenth, nearest hundredth. But the hundredth doesn't matter because the tenths error, the error in the tenths place is 10 times bigger than the error in the hundredths place, and you know it's just it's irrelevant then. So we need to round off somewhere right there to the nearest tenth. So add up normal, 5, 11, carry the 1. There is a 1 up there somewhere. 9, 7, and round it off to the nearest tenth. So the 5 would round up, would make the 1 round up, so I'd get 79.2 for my answer. If I do the next one, 9.44 minus 2.11. If they're all the same, so both of these are measured to the nearest hundredth, then we can just do the math. 7.33, pretty easy problem. Next one, 1.36, 10.17. Once again, measured both to the nearest hundredth, so they're all the same. We just add them up. 11.53. Last one there, 34.61 minus 17.3. Now this one, they're not the same. One's to the hundredth, one's to the tenth. My answer can only go to the tenth, so subtract just like normal. Get that, then round off to the nearest tenth, 17.3 for the correct answer. Number 6, find the total mass of 3 diamonds that have masses of 14.2 grams, 8.73, and 0.912. So here we go, 14.2, 8.73, and 0.912. All right, so on this one, man, they did a great job. They measured that thing to the nearest thousands. This one to the nearest hundredth, but this one only to the nearest tenth. So if there's a tenth or a half of it, you know, usually you can have a maximum of half of your last place. So, you know, 5/100ths of an error on there, that's going to screw up everything else. It's not going to matter what any of those other terms were. So this is how far I can round that off to, or that's where I round it off to. So just add them up. 8, 13, 2. So I get this, and I have to round off to the nearest tenth, so it would simply be the same, 23.8 for my final answer. If we're multiplying, it's not about how far you measure it to, it's simply about how many significant digits you have in that particular example. So if I have 7.55 times 0.34, it's about how many significant digits. So the first one has 3, the second one has 2. My answer is always the measurement with the least. So if I have 2 significant digits, my answer can only have 2. Whatever has the least number, that's what my answer can get. So if I multiply this out, I would get 2.567 on the calculator, and then I need to round off to 2. So I need to round off to that place. So this is going to round up, the 6 is going to round that up, so it's going to get 2.6. If I do the second one, I've got 2.10 times 0.70. Well, let's do this times 0.70. If I multiply those, first of all, this one has 3. Once again, this one only has 2. That first 0 wasn't significant. So my answer can only have 2. So if I multiply that out, I'm going to get 1.47. And I got to round off to 2. So that's right here, the 10th, 1.5 for the answer. Third one, same thing if I divide. If I take 2.4526 divided by 8.4, this one has 2 significant digits. This one has 5. My answer has to have the number in the least, so therefore 2. So when I multiply that out, I get a pretty precise answer. It looks pretty good on the calculator. But putting it down is actually worse than rounding it off, because you're telling me you've measured it to this precision and you haven't. So what you do need to do is round it off to 2 places, so 0.29. All right. Let's do the practice problems on here. Looks like I need to move these up. Let's see. Okay. So work through those practice problems. Once again, stop the video, work through them, come back here when you're done. All right, problem 7. 8.3 times 2.22. 2 significant digits, 3 significant digits. My answer can only have 2. So multiply it out like you would. So 8.3 times 2.22 on my calculator gives me 18.426, but I can only have 2. So I got to round off there. So that would be 18. That's the right answer. Second one, or B, 8.432 divided by 12.5. 4 significant digits, 3. My answer, therefore, can only have 3 in it. So 8.432 divided by 12.5 gives me 674.56. 3 significant digits means that's it right there. This one rounds that up, so it's 675 for the final answer. C, a little bit tricky. You might think not, but it is. 35.2 divide our times 1 minute over 60 seconds. Now what's important about this is that you understand that this right here is a exact quantity. It is a standard. We know that there's exactly 1 minute in 60 seconds. So if I do this on the calculator, I get 0.5866 repeating. And this has an infinite number of significant digits. Infinite. And this has 3. Well, 3 is the smallest of those two, so my answer has to go to 3. So right about there, 5.58 rounded up 7. 587 minutes. That's what you can do. Number 8, calculate the volume of a warehouse that has the inside dimensions of 22.4 by 11.3 by 5.2. Now it doesn't matter how many calculations I do, it's always the one that's the least. So this one only has 2 significant digits, so my final answer has to have 2. So if I multiply it out, 22.4 times 11.3 times 5.2, that comes out to be 1316.224. I only get 2 significant digits. I got to still hold the place, so I'm going to put in zeros there. So 1300 is my answer. All right, hopefully you've done enough of these now. You kind of have a pretty good feel for calculating significant figures if you're adding, subtracting, multiplying, dividing.